Okay, boys and girls, shh, need to quiet down. Um, we left problem B aside on Friday or Wednesday last week, excuse me, and again, that's the type of problem we want to do. It looks like you guys know how to use the chain rule. I think you know how to use the product rule. I think you know how to use the quotient rule. And I think you know how to find derivatives of trigonometric functions. The question is, can you put all those pieces together? So I have a much better idea of how to generate the type of study guide that you guys need in order to really extend your learning and make this a little bit more difficult. So we have two rules that are needed for problem B. We just talked about them. What are they? The quotient and the chain. And because you can see that you have a quotient that you're taking to a power, boys and girls, because you have this is an option. You could do this, and I'm not going to recommend that you do it, but you could do 2 minus x to the 1/2 over 2x plus 3 to the 1/2. And in that situation, what would you do first? The quotient or the chain? Quotient first here, and then you would have two chain rules you'd have to perform. Here, you do the chain rule first, and then the quotient inside there. Question. For the very first portion, yes. Chrissy, were you gone on Friday? Okay, and so we set it up like this. So we have f of u, we have u of x, we have f prime of u, we have u prime of x. And so f of u is going to be u to the 1/2. And u of x is going to be 2 minus x over 2x plus 3. What is f prime of u? One half u to the negative 1/2. And then u prime of x, I have to use the quotient rule. And the quotient rule says I take the derivative of the top, which is negative 1, times the bottom left alone, which is 2x plus 3, minus the derivative of the bottom, which is 2, times the top left alone, which is 2 minus x. All divided by the bottom squared, or 2x plus 3 squared. So I can simplify that a little bit, can't I? I have a negative 2x and a positive 2x, right? Negative 2x minus 3 minus 4 plus 2x. All over 2x plus 3, quantity squared. So you can see the negative 2x and the positive 2x cancel. You're left with negative 7 over 2x plus 3, quantity squared. Am I done? No, I need to take that derivative and multiply it by my original, or I'm sorry, by the other derivative. So f prime of u times u prime of x. And so what we have is negative 7 over 2 times 2x plus 3 quantity squared. But I also need the u to the negative 1/2, right? Which is the square root of 2x plus 3. I'm sorry. Which is the square root of 2 minus x over 2x plus 3. Yeah. Well, yeah, the algebra there is a little bit more involved. Question. Well, so yeah, so I did put it. I put it down there already. Question. No. So, right. So how about this? So, I really put this problem together that you guys would understand, hopefully, that there's a difference between using the chain rule first as opposed to the quotient rule. We won't force us to simplify this right now. I didn't leave a lot of space for that, but it's not that bad to simplify this. It really isn't. Do you want to see it real quick? Let me just show you. It's really not that bad at all. That's fine. You would have to use the chain rule twice then for that. Yeah, go. That's fine. This? Or this? That's your u to the negative 1/2. So being it's to the negative 1/2, it's in the bottom. The 1/2 is the square root, and the u is the 2 minus x over 2x plus 3. So I'll simplify it really quick. Did you write down what I just had? Negative 7 over? Can you read that off to me? Negative 2 over, or 7 over? Okay, so I'll show you how this really isn't that bad at all, you guys. You recognize that if you have a square root of a fraction, you're going to have the square root of the top as well as the square root of the bottom, correct? So I can rewrite this as following. Negative 7 over 2 times 2x plus 3 quantity squared times the square root of 2 minus x over the square root of 2x plus 3. Yes? Right. No, I know you don't see the end product. But we can... For not being here on Friday, Tate, I swear, you sure know a lot of calculus. Okay? So, we have this, and if you write this as negative 7 over 1, I have a fraction over a fraction, right? So let's simply just multiply by the reciprocal. If you multiply by the reciprocal, negative 7 square root of 2x plus 3 over 2 times 2x plus 3 quantity squared times the square root of 2 minus x, right? We are going to simplify that, yes. Look, this is 2x plus 3. This is to the 1/2 power, right? And this is to the second power. If you have common bases, what do you do the exponents? You subtract them. So if I have 1/2 on top and I have squared on the bottom, that becomes negative 3/2. So I'll have 3/2 in the denominator. So this just simply becomes negative 7 over 2 times 2x plus 3 to the 3/2 times, you could write, square root of 2 minus x. So that's it. Well, no, I'm just saying that mathematically, that's how you would simplify it. Now, Devin asks a great question. She says, are you going to put one like that on the test? Do we really have to know this? I would say that if I taught a college calculus course, which I do here right now, I would expect that if you've passed college algebra and you're taking my calc class, there's no shadow of a doubt that you should all be able to do that. So, and if you don't know how to do that, I would expect that you would, go find some complex fraction problems and figure it out, or either that, or maybe you're not cut out for calculus too. So so I'm just encouraging you guys that yes, you should know how to do that. Question. No, I did. So this is 4 over 2 minus 1 over 2 is 3 over 2. Okay. Yes, you can. You can have the square root of x in the denominator, but you cannot have the square root of 5 in the denominator. Okay. Okay, example 3, something different. Okay. Shh. And boys and girls too, do realize that as we're doing material, that we're doing a semester course over the course of the entire year, as opposed to having it 3 times a week. We are having it 5 times a week. So I'm just saying that when I took this course in college, it was 1 semester as opposed to the entire year, and it was 3 days a week as opposed to 5 days a week. So I know it's a lot of content, but you're getting it in twice the amount of time that you normally would, if not 4 times the amount of time. So 50 minutes. Yep. You did a lot of learning on your own. So use the chain rule. It says, suppose that f of x is f of g of x, and f of 3 is 2, and g of 3 is negative 1, f prime of negative 1 is 1, g prime of 3 is 4. Find f prime of 3. This is the key right here. It says find f prime of 3, and you know that f is a composition function. It says f of x is f of g of x. Well, you've learned this, that if you have a composition, f prime of x should be equal to the derivative of the outside with the inside left alone times the derivative of the inside. Isn't that how we wrote the chain rule? We said f prime of u times u prime of x. The only difference is instead of just writing u, I wrote g of x. So it's the same thing, okay? So we just need to identify some key pieces here, all right? First of all, do we know what g prime of x is? I'm trying to find f prime of 3. What is... So I'm going to actually write this out then. What I need to actually find is f prime of 3 is going to be equal to f prime of g of 3 times g prime of 3. This is what I'm looking for. What is g prime of 3? It is 4. So that's easy. F prime of g of 3. Very good. Ben says that in order to evaluate this, we first must find g of 3. What is g of 3? Negative 1. So you will be finding f prime of negative 1, which is 1. No. So, any questions there? Yes, could do that. Write out your composition, perform it. All right, let's try one that's graphical. I'm going to color the one in blue so we can see it better. And then the other one I'm going to color in red. Okay. It says, given the following graphs, let u of x be equal to f of g of x. So u of x is a composition of the two, okay? And it says let w of x equal g of f of x. So again, a composition of the two. I need to find u prime of 1. So I really need to look at this. And then I need to find w prime of negative 2. Now we'll get to that in a second, but this is a good question here. So let's see if we can solve it. If I want to find u prime of 1, and it's a composition, I would say first that u prime of x is equal to f prime of g of x times g prime of x. Does everybody see where I got that? That's the chain rule. If you don't see it, you have to memorize this chain rule, which is f prime of x is equal to f prime of u times u prime of x. And all I've done is instead of writing just u, I wrote u of x or g of x. So that's all that is. That's the chain rule. So the question is, can we first identify this? Okay, I'm going to put in some numbers. What are we trying to find the derivative at? 1. So we have u prime of 1 is equal to f prime of g of 1 times g prime of 1. This is really a math teacher's question. The reason why is it requires you to have knowledge of the rule as well as the graphical understanding of what it means to be a derivative. In plain terms, can you tell me what a derivative is? Slope, rate of change, instantaneous rate of change, anything like that is fine. So we're just looking at these type of slopes. So if I say g prime of 1, I'm wondering the slope of g at 1, right? So at 1, g is the red function. What's the slope of g at 1? Let's see, it goes over 1 and up 1, 2, 3. So the slope is 3. Now I need to find f prime of g of 1. First I need to identify what g of 1 is. What is g of 1? 2. So I have to find f prime of 2 and then multiply that by 3. What's f prime of 2? So I look at 2, which is right here, and the slope of the function is not 2, but negative 2. So the slope of this function is negative 2 at that spot. So I have negative 2 times 3, which is negative 6. Uh, 2 is what g of 1 is equal to. If I plug in 1 to the function g, I get 2. Yep. Yep. So let's switch it now, okay? You guys found that one, and we'll walk through it again. Just same type of process. Now we're going to do w prime of negative 2. And we're going to plug that in for this spot right here. So the first thing that I like to write is w prime of x is equal to, who can finish this part off for me? Good. The derivative of the outside with the inside left alone times the derivative of the inside. Because of this rule right here. So it says w of x is equal to g of f of x. So it's the composition the other way around. Okay? Now I need to define it. At what point am I finding the derivative? At negative 2, so I'm going to plug that in. So w prime of negative 2 is equal to g prime of f of negative 2 times f prime of negative 2. And now we go to business. So I'm now looking at negative 2. What is the slope of f at negative 2? Positive 1. Now I need g prime of f of negative 2. So what should I identify first? I first should identify f of negative 2. What is f of negative 2? Positive 5. So I have g prime of 5. Now I have to figure out the rate of change of g at 5. If you go over here, 5, you go up to g. What did you say, Chris? 1/4 is the slope of g at that spot. So you have 1/4 times 1, which is 1/4. Yeah, so w prime of negative 2 is equal to 1/4. That is correct. And one more question. Find the equation for the line tangent. Remember, this was the first problem we started out with at calculus. How do you find the equation for a line tangent to a curve at a given point? In order to find the equation for a line, I need how many things? I need two things. I need slope and I need point on line. So, do we know our slope yet? No. Do we know our point on our line? What is it? So, point on the line is, we have 1, negative 1. What'd you say, Gertie? Greta? At what point? Sure, the derivative of f at 1. That's what we're trying to find. So let's see if we can do that. I want to find the derivative of f at 1. So, what do I use? Chain rule. So if f of x is equal to 2x minus 3 to the 5th power, and you want to find the derivative of that, you use the chain rule. I find the outside, which is u to the 5th, the inside, which is 2x minus 3. The derivative of u to the 5th is 5u to the 4th. Derivative of 2x minus 3 is 2. I take my u and plug it back in, multiply these together, I get 10 times 2x minus 3 to the 4th power. No, we're not done. So that's f prime of x. I still don't have my slope. Up to the 4th. What do you have to plug in? Plug in 1. Okay, so we plug in 1. What is 2 times 1? Minus 3. To the 4th? Positive 1 times 10? Attaboy, Nathan. So, my derivative is 10 at 1, which means my slope is 10. I need to write an equation for a line. Y equals mx plus b. Our final answer, y equals. That's the equation for the line tangent at that given point. What other way? Oh, it should have taught you derivatives right away? Well, if you remember, isn't f prime of x really the limit as h goes to 0 of f of x plus h minus f of x over h? That's so we had to spend some time focusing on that first. Yes, exactly. You make my point. We could have done the easy ways right away, and then you would be just like the kids who show up to college and they say, I know how to find the derivative of 3x squared, it's 6x. And the professor says, prove it using this. They're like, I have no idea how to use that. Why would I ever need to use how to use that? And you say, forget it. All right, your assignment.